For those of you new to the channel, 3I Atlas is the third confirmed interstellar object ever discovered, and it's rewriting what we thought we knew about the cosmos. This object is not just another icy wanderer, it's a traveler from a completely different star system, passing through our solar neighborhood for the very first time, and possibly the last. And today, October 29, 2025, marks the most critical point of its entire journey, perihelion, its closest approach to the Sun. At this moment, 3I Atlas is just 1.36 astronomical units away, roughly 126 million miles, placing it between the orbits of Earth and Mars. It's now being bombarded by immense solar radiation, exposed to temperatures hot enough to melt lead on one side and freeze nitrogen on the other. For most comets, that kind of heat would ignite a spectacular display. Ices sublimating, gases venting, tails expanding, a fireworks show of dust and plasma that obeys every known rule of celestial mechanics. But this time, the universe didn't play by the rules. When Atlas first detected the object in July 2025, astronomers thought they knew what they were looking at. A faint, fast-moving dot with a predictable trajectory. Its orbit was hyperbolic, meaning unbound to the Sun, and its velocity, more than 58 kilometers per second, confirmed it had come from outside our solar system. In short, a new interstellar visitor, the third ever, after Oumuamua in 2017 and Borisov in 2019. At first, the data made sense. Its orbit was clean, its speed consistent, its light curve steady. But then in the weeks that followed, the object started to deviate, slightly, subtly, and then unmistakably. Its brightness didn't increase the way it should have. Its tail didn't point away from the Sun like every other comet's tail does. And its acceleration, the small nudge comets get when their ices vent into space, wasn't behaving normally either. The deeper scientists looked, the more they realized this was not just another frozen rock. Right now, as it skims closer to the Sun than ever before, 3I Atlas is undergoing a kind of stress test, the moment that will decide which theories survive and which will burn away. For the astronomers who believe it's purely natural, this is an unprecedented opportunity. They're watching how the comet's chemistry evolves under intense heat. Will water vapor levels increase as deeper ices are exposed? Will the CO2 to H2O ratio remain unusually high? And how will the coma's brightness change once the heating peaks and begins to decline? If 3I Atlas behaves like a normal comet under these extreme conditions, it could help scientists understand the diversity of interstellar materials and the thermal history of exoplanetary systems. But for those who believe this object might not be entirely natural, perihelion is something else, a moment of truth. If 3I Atlas emerges from behind the Sun next month on a trajectory that outgassing alone can't explain, then every assumption about what this object is will be back on the table. To appreciate why this is so important, we need to go back to what made 3I Atlas so strange in the first place. From the very first observations, something was off. Even before it got close to the Sun, when it was still well beyond the orbit of Mars, the comet was already active, glowing with a visible coma. That's not supposed to happen. Typical comets remain inert until sunlight begins to warm their surfaces. But 3I Atlas was venting material far earlier than expected. When Hubble and JWST turned their instruments toward it, they found something even more puzzling. Its chemical fingerprint was unlike any comet we've ever studied. Its coma wasn't dominated by water vapor, like our comets are. It was dominated by carbon dioxide, and not by a small margin. Some observations showed one of the highest CO2 to H2O ratios ever recorded in any known comet, inside or outside our solar system. If our comets are dirty snowballs, made mostly of frozen water, 3I Atlas is more like a ball of dry ice and rock. That means it likely formed in an environment much colder than our solar system's outer regions, possibly in the far reaches of its original star's disk, beyond the CO2 snow line, or in a completely different chemical environment altogether. This single detail makes 3I Atlas a chemical messenger from another planetary nursery. carrying clues about worlds that may have formed billions of years ago in another corner of the galaxy. But chemistry wasn't the only oddity. When high-resolution images arrived in August and September, astronomers noticed something almost never seen so clearly before: a sunward-pointing plume. In plain language, its tail, or at least part of it, seemed to be pointing toward the sun. That goes against the basic physics of comet behavior. Normally, sunlight and solar wind push gas and dust away, forming a glowing tail that trails behind. But 3I Atlas had what's called an anti-tail, a rare phenomenon that can sometimes occur due to perspective or dust plane effects. Even so, modeling suggested there was more to it, possibly large ice grains being expelled by the sublimation of CO2 gas, forming a visible plume that resisted the sun's push. In September, that feature faded, replaced by a normal outward-pointing tail. But that brief reversal was enough to remind astronomers that interstellar objects don't always play by local rules. Then came the non-gravitational acceleration, the small, measurable deviations from a purely gravity-driven orbit. Every comet has them. Jets of vaporized gas act like mini thrusters, pushing the nucleus slightly off course. But 3I Atlas's acceleration wasn't behaving like any known model. It was steady when it should have fluctuated. It shifted direction more than once, without corresponding changes in brightness. And when scientists tried to fit it into conventional outgassing models, the residuals, the tiny errors left over after you subtract the prediction from reality, didn't line up. That might sound minor, but in precision orbital mechanics it's everything. When something in the sky doesn't move the way gravity says it should, you investigate. First, you check your math, then your instruments, then your assumptions. And if none of those explain it, you're left with questions that make people uncomfortable. And that's where Avi Loeb, a Harvard astrophysicist known for his bold hypotheses, enters the story. He's not saying 3I Atlas is artificial, but he's asking, what if it isn't purely natural? Loeb argues that the object's timing and behavior make it worth considering that possibility. He points out that perihelion, the point of maximum velocity, is also the perfect moment for an outburst maneuver, a real physics concept where a spacecraft uses a star's gravity to amplify a propulsion burn, changing its trajectory with maximum efficiency. If an advanced probe were ever to adjust course while passing through our system, perihelion would be the time to do it, and solar conjunction would be the perfect cover, because the object is hidden from Earth's view behind the sun. It's an extraordinary claim, and the vast majority of scientists don't buy it. The evidence still supports a natural explanation. But Loeb's challenge serves a purpose. It keeps the debate honest. It forces researchers to test their assumptions to the limit, and to be precise about what unexplained really means. For now, the focus remains scientific. NASA, the European Southern Observatory, and independent observatories across China, Chile, and Hawaii are coordinating their next observation windows. Hubble will watch from Earth orbit. JWST will analyze infrared signatures once the object re-emerges in November. Ground-based systems like VLT, Gemini South, and Subaru will measure its brightness curve, tail morphology, and composition as it cools back down. Every spectrum, every pixel, every motion vector matters, because these are clues to a much bigger question. What are interstellar comets really made of, and how common are they? 3I Atlas may never return, but what it leaves behind is priceless. Hard data about chemistry beyond our solar system, evidence that our universe is chemically richer and stranger than we imagined. This comet is a time capsule from another sun, a frozen piece of another world's origin story. Its ratios of carbon dioxide, cyanide, nickel, and water, the fingerprints of its birth, tell us that planetary systems can form under wildly different conditions, with materials we barely understand. And while the talk of alien technology makes headlines, the truth might be even more profound, that the building blocks of life and planets are more diverse, more unpredictable, and more widespread than we ever dared to believe. So as we speak, 3I Atlas is racing around the sun at over 240,000 kilometers per hour, hidden in the glare, bombarded by heat, stripped of its frozen skin, And when it reemerges next month, astronomers will compare every data point they've collected before and after this moment. If its brightness drops sharply, we'll know its surface has exhausted its volatiles. If it brightens unexpectedly, maybe it fractured. And if its orbit doesn't match the math, the questions will only grow louder. Either way, this is one of the most important astronomical events of the decade. The first time humanity gets to watch, in real time, how an object from another star system behaves as it passes through ours. Whatever story 3I Atlas tells when it returns to view, one truth is already clear. We live in a universe that refuses to be predictable, a universe that constantly reminds us to stay humble, to keep asking, keep observing, keep wondering. Because somewhere out there, in the cold dark between the stars, there are countless others like 3I Atlas, each carrying its own secrets, each whispering a message we've only just begun to hear. And as of today, that whisper is closer than ever. This is perihelion. This is the moment of truth.